Hello friends, welcome to Truth of Physics. Today in this particular video I will discuss what all about time evolution operator and space translation operator. First I will discuss infinitesimal and then we will converge to finite translation and time evolution. You all know in quantum mechanics to get we have suppose a state gate alpha which is at t equals to 0 of a system, the state gate. Then what will be the state gate after some time t? What will be that? How can we represent, or how can we know the information? We just operate this operator to the power minus I h t over h cut. This h is the Hamiltonian of the system. T is after some time t, after t time suppose. So if it operates on this state gate at t equals to 0, it will give some answer like alpha dash say. So this thing will represent the state of that system after some time t. Okay, now how it becomes the time evolution operator, that I'm going to discuss in this video detailedly from the basic principles. Okay, and okay, now from from the space translation I will convert to time evolution. You will easily understand each and every concepts after watching this video till the end. Suppose from the very basic I am considering, suppose we have an operator like this dx dash. If this operator acts on any gate, suppose we have this position gate, and if we apply this thing on this gate, position gate, then what we'll get? We'll get the same state. Okay, all the things, everything will be just same, like the spin direction for example, and all the details will be just same, but we'll get due to this operation of this infinitesimal translation. This is called infinitesimal translation. Operating on this state gate, it will give what? It will do the same state gate but to another translated space, or in some another well localized state like x dash plus dx dash, and everything remains just similar like this, every property like similar like this. Just this is just translated in space to dx dash in the forward direction, in the rightward direction. Right now you can easily understand that if this happens, then this operator operating on this and gives this thing, then you can understand that this state gate is just changed. That means this x dash, more simply you can say x dash, this state gate is not an eigenstate of this operator I dx dash, because it is this state is just changing after the operation of this operator on this state gate. Now we have to understand one thing, that any operator, suppose alpha, can be expressed as a linear combination of some base pairs. If we want to take the base pairs to be the position eigengates, then it will become just like this. If we discuss about discrete spectrum, then it will be like this, C A dash, some constant, okay, some coefficient, and like this. And if you want to represent, okay, this will become, so this can be converted to like this constant will be like this, x dash and alpha. How will you get this? And this is this. So why I have written this in front like this, and give this in back position like this, and how this comes, this is just multiply, just take the inner product here and you will get the value of the coefficients. Okay, so all the things I have this is called the legal and illegal notations. So all the things I have discussed in several videos of, you can get the videos from the quantum mechanics playlist, okay, in this channel. I will give the link in the description box. You can check out the video on completeness theorem. There I have also discussed how these coefficients become this thing. So okay, now if you make this in continuous spectra, this is in discrete spectra, if you make this in continuous spectra, then this summation will be converted into integration and dx dash. So this becomes integration dx dash x dash and alpha, this inner product. Now if you apply the infinitesimal translation operator I dx over this, so this will operate on the state gate, so this will operate on here, right? This will operate on total thing and give rise what? This will become just dx dash integration, x dash will just be transformed like this here, means x dash will be x dash plus dx dash, and this will be just same. Now you can easily understand that we are discussing from the very basic, right? We have defined a infinitesimal operator like a very general sense, like an infinitesimal operator is such operator which operate on a state gate, suppose x dash, and just translates its position to x dash plus dx dash. This is just the operation of a infinitesimal translation operator, which is very clear from its name also. So it is just translating this thing, so it will become this. Now as the integration is over all space, right, and x dash is as x dash is just a integration variable, so we can just convert it, or we can just replace this thing, right? Replace this variable with x dash minus dx dash. All the things will be just same because of this operation, because we are integrating over all the space, so every point is just similar. So the differentiation will be just dx dash will be just same. The old dx dash will be just similar to the new dx dash. So dx dash will be just same dx dash after the operation of or after the replacement of this thing. X dash plus dx dash, put the thing x dash minus dx dash in the place of x dash. So this thing becomes now x dash, and this thing now becomes x dash minus dx dash and alpha, and there is integration. Two things, both of these two things are similarly valid. This is what this represents, that here we are considering that state gate is translating, right? State gate is translating space due to the operation of this identity operator, infinitesimal translation operator. And in this approach we are assuming what? The state gate is not changing, but the origin is shifted in the opposite direction. The origin is shifted in the opposite direction, right, in minus dx dash. So both the things are similarly valid, but we can stick to only one notation or only one notion. Now we are going to derive the proper expression. What will the proper expression of I dx dash, this operator? Now for that we are considering some conditions or some properties of this operator, like it's very simple thing that we have assumed that the operation of this thing is only to change the coordinates, or to translate the system, the state in some another well local state like x dash plus dx dash, right? So this is only this is the only operation of this operator. That means if a state, suppose alpha is a state, is normalized initially, okay, before the operation of this thing, if it is normalized, that means alpha, this product is equals to 1, then after the operation of this operator on the on alpha, then also after the operation we'll get suppose alpha dash, then also this alpha dash will be what? Normalized, because its operation is only to translate in space, not and do nothing. So alpha dash will also be normalized. So alpha dash will also be 1. Now alpha dash will be what? Alpha dash, this will be what? This is just I dx dash and operating on alpha, right? Now just take the dual correspondence of the total thing. That means this will become if you want to calculate this thing, that will become just, this will be just this become the this gate become the bra, means this, and I of dx dash, and this its dagger, right? So this will become just alpha, this dagger dx dash I dx dash and then alpha again. Now as this is 1, so for this to be 1, this must be equals to 1 because we know alpha 1, this is 1. So for this total thing to be equals to 1, you must have this condition, right? I dagger I is equals to 1. Now you may think that what is this condition? This is nothing but the condition of unitary operator. Now if you want to understand clearly from the basic what is a unitary operator, I have made a dedicated video, you can watch that video, I will give the link in the description box. Now this is the condition of unitary operator, that means the I infinitesimal translation operator is unitary. This is number one property. The second property, we can think very easily that if we successively do two translation, infinitesimal translation like this, first translate dx dash amount, then translate dx double dash amount, then you can easily understand that after the operation of this thing, the state will become something like x dash plus dx dash, right? And after and we have to then operate this thing, this is the intermediate state, okay? And then we'll get something like x dash plus dx dash plus dx double dash, something like this. So as a whole we can think that this is what, this is equivalent to operating I dx dash plus dx double dash, operating on what, x dash. So this is dx double dash, d identity of dx dash operating on x dash, right? Operating on x dash. So I can write, this is the thing, right? This is our second property. Now the third property, we can think that identity inverse of dx dash. Now what is the inverse actually means? Means suppose we are operating I dx dash on some gets suppose x dash, then it becomes what, x dash plus dx dash. Now if we want to revert the process, means we should get back to this. If we revert the process means what, just inverse operator dx dash, if it operates on this thing, right, plus dx dash, then we should get back x dash, right? That means the operation of this is just what, the operation of I minus of dx dash. So this is another important property. And the fourth property is, or fourth property should be like this: limit dx dash tends to 0, I dx dash, it should be equals to 1. Means when we want to make this limit to 0, means we are just translating very small amount, okay, very small, this distance is very small, dx prime is very small, then obviously this identity this translation operator will converge to just identity, right? Because we will get the same state, because, right, means x plus dx dash, this tends to 0, means what, the state itself, the previous state x dash. So this is 1. Now these are all the properties. Now you may think, or I can give you a simple statement that our identity operator will be like our infinitesimal translation operator have the form of like this. Why? Because what will be the thing to check this? Check all the properties that I have discussed, 1 2 3 4, and you will get that yes, this will be exactly fitted in our exactly fitted to be the identity operator, the expression of the the expression of the translation operator. How? Let us understand, or let us do two properties, the first two properties. Now the first property was this thing, dx dash, the this translation operator should be unitary, so this becomes 1, so this should be become 1. So what will be this? 1 minus I k I k dagger dx dash into 1 minus I k dot dx dash, right? So it should, wait, here should be plus 1, because when we dagger it, then due to this I, its dagger, i's dagger becomes minus I, so there will be, this will be plus, so it will happen. Now what is k? What I have not mentioned, that k in this expression that I have just asserted, this k must be a Hermitian operator. Hermitian Hermitian operator. Okay, and it just make a psi here, a state here, and just operate sequentially. First this thing on this, right? Then it becomes psi minus I k dot dx dash, and then psi, and then operate this thing 1 plus I k dagger dx dash. Then you will get like this 1 minus, and just and you will get some. And when you operate this and this, you will get something like dx dash into dx dash, and you can neglect this term because these two things are very small, and the multiplication or the square will be very small, so you can neglect this and you will get something like this: 1 minus I k minus k dagger dx dot dx dash. And now as k is Hermitian, k, that means k dagger will be equals to k, so this will become 0 and we'll get just 1. So I dagger into I is becoming 1. That means the Hermitian the unitary property is satisfied by the relation. Now the second, x double prime I dx prime. If you do this, then what will get? 1 minus I k dot dx double prime, or 1 minus I k dot dx prime, right? And what? Okay, so this similarly, if you do the things, then it will go like this: 1 minus I k, okay, dx prime plus dx double prime. Okay, just do the similar things, right? So you can understand that this will become a minus when operated on this thing, and you'll get a minus again, and when one will operate on this, or these two things, right? So the minus will be taken outside and you will get something like this. So it is what? It is just I dx dash plus dx double dash, right? So this property is also satisfying. So you can check the other two properties also, and that will also be satisfied by this simple thing, by this simple expression that we have asserted. Now, so from the basic things, we have come to a very good conclusion, not full conclusion, but a half conclusion, like our infinitesimal translation operator would be something, the form of this operator would be something like 1 minus I k dot dx dash, this thing. Now what will be the k? What will the value of k? Let us understand that, and for that we have to use the classical analogy of infinitesimal canonical transformation, ICT in short form. From classical mechanics, we know that if we have only translated our coordinates like x new, right, is just x old plus dx dash, and our momentum is just same, that means p new is just the old p, then this type of translation, for this to happen, the generator, what will be the generator or the generating function? The generating function will always be the momentum p. The generating function is expression f x comma p, because only qp, right, q is the coordinate, okay, generalized coordinate, and p is the generalized momentum. If it is only qp, then you can find that this type of this is called generating function, okay, of canonical transformation. Now if this type of transformation happens, then you will get identical transformation, means x dash, new x dash will be just x, and new p dash will be just p. So that will not work, because here x plus dx dash means it is infinitesimally changing, and that's why this is infinitesimal canonical transformation. And that for that to happen, we have to add something with this, and that is plus epsilon, okay, a small parameter into dot uh, dot, more generally I can write g dot g, where g is what? G is also a function of q and p. You may check out a video I have made dedicatedly and very detailedly on how momentum is a generator of translation, and our Hamiltonian is a generator of time evolution. This is very much important to understand. Okay, I have made a video. You can watch that video, and you must watch that video to understand this concept clearly from the very basic. Okay, so from that video I can give the conclusion, like here if you consider the epsilon to be the position dx and g to be momentum. Okay, if you let if you think g the momentum and epsilon the dx, then for that case you will get the transformation, the time the space translation x plus dx dash. So momentum is a generator of infinitesimal translation in space. And similarly, if you take g to be our Hamiltonian and epsilon to be dt time, then you will get what? For this thing you will get that it is evolving with time. Okay, you will get the equations of evolution. Some system is evolving, or system is having a evolution in time. Okay, what we have got from this conclusion, that momentum is a generator of infinitesimal translation. So here, what is our infinitesimal translation operator? I dx dash is equals to 1 minus I k dot dx. Now we want to find this. What is this k? Now you can think that here the operation of this is also infinitesimal translation, and we have discussed that momentum is also doing the same job. That means k is somewhat related to the momentum, right? Because these two things are doing the same job. But if you think from dimension analysis, then what will the dimension of k? To find the dimension of k, we know the dimension of this quantity. Now it is subtracted from 1, right? From a number. This is a number. So anything subtracted from a number or anything subtracted from a quantity, that should be the same dimension of that quantity. Means as this is this part is subtracting from 1, that is dimensionless, so this part should also be dimensionless. So for this to be dimensionless, k dot dx, this should be dimensionless. How that can be happen? This is dimensionless. How that can be happen? K should be equals to 1 by dx, or k should be the dimension of 1 over length. It is not matching, right? It is 1 over length and its momentum, it is not matching. That means we have to consider some more factor in this scenario. Now, so k should be what? K should be something, momentum, it should be related with momentum obviously, but divided by some constant, okay, some universal constant, action, which have dimension of action, because then only you will get what? You will get that 1 by length. The total, if you calculate this, then we will get 1 over length, the dimension of this. Now what will be the universal constant? Scientists have found that this universal constant to be p over h cut. Scientists have found this universal constant h cut. So k is becoming our p over h cut. Okay, now if you calculate this thing, you will get this 2 pi over lambda. So actually our k is nothing but the wave number 2 pi over lambda. Lambda is the wavelength, right? De Broglie wavelength. Now, so what will be the I dx dash? It was 1 minus I k dot dx dash. So replace the value of k, 1 minus I p dx, this thing, replace with this thing, I p dot dx dash over h cut. So this will be the exact form. Now this is not enough. We want to find more compact form. What is that? It is what? It is an infinitesimal translation. Now if we want to find the finite translation, then we have to do what? Successive infinitesimal translations, right? Due to the property we have discussed that successive translations will give rise to a finite translation, right? Like dx dash, then we'll do I dx double dash, then it will gradually become I dx dash plus dx double dash plus dot dot dot, and that will become a finite thing that will give a finite displacement. So what we can do, suppose there is a finite displacement of dx del x dash. Okay, this is finite, but we can chop it into n terms or n number of small divisions, and each displacement is of dx prime. Okay, so there are dx prime, many dx primes, each have the length of dx prime, and the total is delta x dash. So dx prime into n, and there is n number of terms here, n number of terms. So n into dx dash will just give you dx dash. So what will be our dx dash is equals to delta x dash over n. So to find the finite space translation operator, this thing in the x cap, okay, in the x cap direction, we have to do what? We have to just take a limit where n tends to infinity. To make this measurement more precise, we can make this, right, very small. You can understand it with your knowledge of numerical analysis, where we did where it does this kind of job, right? If we take n to be infinite, then means the precision or the accuracy will be greater. So n tends to infinite, and then what? And then so we repeatedly do the operation of this kind. Okay, I of dx dash, then again I of dx dash. We are repeatedly operating these things. That means we'll get what? We'll get this type of things, 1 minus I p x, because it is in x direction, x cap direction. That means I p x into delta x dash. This is what? Delta x dash over n. This is just dx dash. Okay, delta x dash over n, this thing into h cut. So successively you are doing this thing. That means you will gradually multiplying this with this and this with this. So you will have n number of terms, so it will become n. So 1 minus I p x delta x prime over n h cut whole to the power n. So if you take the limit, you will get something like this: px delta x dash over h cut. You will end up with this compact form. So if you want to write this explicitly, then the finite space translation operator will be, the form of this operator will be like e to the power minus I px delta x dash over h cut. And sorry, it should not be delta, because I have written here dx dash. It should be dx dash. Now similarly, if you want to find the time state gate after time evolution, okay, after some time, then what we'll get? Then the time evoluted state gate will be like e to the or the time evolution operator will be like e to the power minus I. In place of p, there will be what? H. This is p operator. This is Hamiltonian. In place of ds, you will have to use dt over h cut. Or for finite thing, e to the power minus I h t over h cut. Why h and t? Because if we take g, that I have discussed here, if you take g, h and epsilon to be t, then you will get a time evolution that I have discussed in that video, okay, of classical mechanics playlist. I will give in the description box the video links. So thus you get the time evolution operator, and this is what the time translation operator. Okay, so this is all about today's video, that how you can generate or how you can derive the expression of time evolution operator and space translation, infinitesimal and finite space translation operator, using the basic concepts, okay, of quantum mechanics. So I hope this video is very much helpful and you have understood all the concepts. If you have any doubt, then you can comment below and share this video with your friends. So take care of yourself. Thanks for watching.